Yeah, hey everyone, this is Dwayne with GoodWorks Auto and Dwayne's Diagnostics. And I'm actually doing a video today about the 2003 F250 Super Duty Powerstroke 6.0 turbo diesel that I did my last couple videos about. And I told you, for anyone who was watching, I said that I would do some battery load testing on it and some relative compression testing on it. And that's actually what these waveforms here are, is the relative compression and basically the battery voltage or battery load while it was cranking. And I actually had done two videos on it. Actually, I did a video on it testing it the other day, and I accidentally ended up deleting the video off my phone. So then I did another video on it this morning, and actually got all kinds of stuff in that video. I had all kinds of stuff to show you and tell you about, but that video ended up kind of being a long one. I kind of rambled on that one, but I squeezed a lot of stuff in there too, and had a lot of stuff to show. But that video ended up being, I think, about 27 minutes. And then when I saved it to my phone, it saved the video like sideways, so it was playing like sideways. And I don't know how to fix that on this recording app I have. I don't think there is any way to fix it. Just whatever, the way it saves it, I don't think you can go back and change it. So and then it was eating up all the storage space on my phone, so my phone was acting kind of goofy. So I actually ended up just deleting that video today too. And I was gonna go back out there and test it again, try to make another video, but actually was a little leery about testing that battery anymore, because when I was out there this morning, I had only cranked it over a couple times. I think only 2 times. And after the second time I cranked it, I went out to check it. I had one of my other battery testers hooked up to it, and I could hear that battery. It sounded like that battery was gassing like really bad, like it had been possibly boiling. I could hear it gassing really bad. So I was a little leery about doing any more testing on that battery, just because I didn't want it blowing up on me. And I can actually show you in these waveforms why why it was probably sounded like it had probably been boiling and gassing like that. And it actually I actually learned a lot about diesel batteries and testing diesel batteries on this one. And if you can see here, this is the this is the amperage that this line here that spikes up. This is right when the starter powers on. This is the amperage that the starter is drawn when it starts to turn on. And you can see up here it's at 792.5 amps, which that battery is only rated for 750 cold cranking amps. So trying to start this motor was actually just maxing that battery out, which is probably why it heated up and probably started boiling and sounded like it was gassing, because it was just maxed out. And I can show you the levels here. This is while it's cranking, and that's up to about 630 amps while it's cranking. So it's drawing 630 amps while it's cranking, which is, you know, basically just maxing out that battery. So I could see why it would heat up and gas like that. And now I can see why you need two batteries on, I guess, on most diesel trucks. I can see why you need two batteries, because that thing was just sucking the amps out of that battery, and you know, dropped the voltage down pretty low. So I can see why you need two batteries on diesels. I've never actually worked on too many diesels, other than I've worked on a couple tractors, and I've worked at shops where you know, I've done oil changes and changed fuel filters, and probably tires and stuff like that on diesels. I've changed some batteries, but I've never actually had to do any kind of diagnostics on any diesel trucks. So a lot of this was kind of a good learning experience for me. Actually learned quite a bit about diesel batteries and relative compression testing on diesels. They don't have a clear flood mode where you can kill the injectors basically by holding down the accelerator pedal. At least this one didn't. And from what I heard and found online, some guys were saying they do have a clear flood mode, but most guys were saying they don't. And I don't think they do. This truck didn't. I tried to actually command the fuel pump off, which I was able to do that with my scan tool. But then as soon as I went to try to crank the truck, the computer just automatically turned the fuel pump back on. So I tried it the way with holding down the gas pedal, and that still didn't turn the injectors off. So I don't think there is an automatic clear flood mode built into, at least not built into this diesel that I know of or know how to do. So so I couldn't do a real true relative compression test, but this is basically a relative compression test. This is one though where the truck, I didn't have the fuel disabled, so the truck actually did start. Over here is actually where the truck did start, and this is where it's running. So it's not really a true relative compression test in the way that the fuel wasn't disabled on this truck, but you can see from what I'll show you here, it's still a relative compression test. And that's what another thing I can show you on this is these these peaks here, right here, right here, right here, right here, right here, or guys call them humps. They look kind of like triangular shape, but this right here, the top of it is where the cylinder is reaching a top dead center compression on the compression stroke. So each one of these is one cylinder hitting top dead center on the compression stroke. Pulling about 630 amps. And this is actually a good test to see if you have a compression problem. Like on this one, this peak here on this cylinder is a little bit lower than the other ones, which that could indicate some kind of mechanical compression problem. But actually on this engine, that I'm not sure why it's lower on that one. That might just be because the engine's first starting to move. I don't know, some kind of fluke on here. But I have another, I got another waveform of this truck cranking, and there is no, all the cylinders are the same on the other waveform. So I'm not sure why this one showed up lower on this, but for some reason on this one, it is showing the compression is a little bit lower on this cylinder compared to the other ones. I'm not sure why. I don't think it's any problem though, because it didn't show up on the other waveform that I took. But yeah, there's all kinds of things here you can do with the scope. All kinds of measurements you can make. Like I could put cursors here, like from there to the next peak, and that'll actually tell you the RPMs. You see it down in the corner, 427.63 RPMs. But there's actually a lot of cool things I found in this waveform, and think that I figured out in this waveform. There's a lot of cool stuff on here that I found. Kind of hard to do this all and operate the laptop at the same time, but I can show you one of the things I found. Well, I'll show you right here. This is where the glow plugs are turning on at about 100, pulling about 162 amps, and then the fuel pump is kicking on and whatever else is turning on in the truck. But I think most of that amperage right there is being drawn by the glow plugs. And I can actually zoom in on this and show you something, or actually I'll pull the voltage down here. I guess I gotta move over here. Pull this voltage down. Show you something going on in here. But this right here, the computer is pulsing something right here, which I don't know if it's the glow plugs or possibly the injectors, but I can measure it. And it's whatever it is, it's dropping down about 15 amps, 15 and a half amps, and it's pulsing it. When this red line comes up, that's when the amperage is coming up. That's when whatever it is being turned on. And then when the line drops down, it's being turned off. And it's turned off right there, and then it gets turned back on. The amperage rises up, then it gets turned off, and it drops down. Same thing with the voltage, but the voltage does the opposite thing. The voltage will drop when it gets turned on, and then it's turned on. It'll rise when it gets turned back up, when it gets turned off. Or this is pulsing it backwards, actually. Looks like this is pulsing it backwards. So it's pulled down to ground. Let me pull out a ruler here. Okay, no, I was looking at it wrong. This looks different from my angle. Yeah, the voltage gets pulled down when this thing gets turned on. It's pulled down, it's turned on, then it gets turned off, so the voltage rises back up and this amperage drops back down. And whatever it is, this 15 amps or so, it's sitting on top of the 160 amps, which I think is mostly from the glow plugs being turned on. You can see that's the thing I was just looking at, and that's the voltage where it's at, is 160 amps up here. So I don't know if that's the glow plugs or that's the injectors or the fuel pump or something else that I don't know about, because I'm not an experienced diesel diagnostic guy, but something's getting turned on and off there. Whatever it is, something's getting turned on and off there, pulsed and dropping down about 15 amps. And my guess, I don't think it would be the injectors, because the engine hasn't even started trying to move until right here is where the starter gets turned on. So I don't think the computer would be pulsing the injectors way back here, but it might be, I don't know. So something else I can show you that I thought was kind of cool. Is this is the voltage line, the blue trace. But you can see these little pockets where the voltage is dropping down right here. That's that little pocket. But this little pocket lines up actually with top dead center of the pistons. So I think this is actually when the injectors are being pulsed. It's a square wave looking pulse, and something's getting turned on right there. The voltage drops, stays down, then it gets turned off, the voltage rises back up. And I measured it before, and it looks like about the same time as a fuel injector would get pulsed. It was about like 6 point something, 6 to 7 milliseconds. And it could actually go up here in that this is top dead center of the cylinder of the piston of the cylinder, the piston coming up here on each compression stroke. And if you notice, it has a same little pulse that looks like that on the amperage right at the peak. So it matches up with that little pocket on the voltage. These line up. See that? It lines up. And I actually had it measured, and it was about 20 amps. That's about when that thing turns on. Right there you can see 17.79 amps. And I could actually measure the time of it too, but I don't want to make this video super long and bore everybody, but this is actually interesting, cool stuff to me. Something else I noticed is it looks like it only takes the engine about about 2 revolutions to actually get started. Because I think it takes 2 revolutions for all 8 cylinders to get through like an entire firing cycle, the 4-stroke cycle. And if you count here, here's 1 cylinder, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's about 2 revolutions, I believe. And then 1, boom, and right there it starts. So it looks like it only takes actually about 2 revolutions if I'm right on that. You know, it's been a long time since I studied all that engine theory stuff, and I don't deal with engine stuff all the time, but I think that's correct, is that it would take 2 revolutions to go through for each cylinder to hit its compression stroke. So it looks like it only takes like 2 revolutions of the engine, and then right here it starts. So I thought that was pretty interesting to see on there. It only takes 2 revolutions to get the truck started. And something else I was going to show you. Redo that one. Yeah, maybe redo that too. So right here is where the truck starts. Basically, that's where the engine actually gets moving and going, and it's not having to be turned by the starter. But we got these other little pulses here that those seem to agree with those pulses on top dead center that I'm thinking are the fuel injectors. You can see these little pulses in here. One there, one there, one there, one there, one there, one there. And they're kind of more spaced out over here than they are over here, because like the engine's spinning slower over here because it's still trying to crank it over and get it started. So it's not having to pulse the injectors as fast. But then right here the engine starts, and then you can see those pulses start becoming quicker and quicker and quicker. And then right here it gets started, and that's where it's running. So I'm not totally sure on that, but I believe those are the pulses of the injectors. And they actually measured about the same amperage as these other pulses over here on the other side of the waveform before the truck even tries to start. These ones they actually measured about the same amperage. 21.5 amps. And could actually measure the time on them. About almost 5 milliseconds, 4.79 milliseconds, which is about the same time as an injector might pulse on a gas vehicle. I assume it might be about the same time on a diesel, I'm not sure. But that's what I'm assuming, is those are the injector pulses. And that's where the truck is actually running. And looks like those pulses pretty much stay the same, about the same time, same amperage pretty much. But anyway, this video is getting pretty long, so I better cut it off now. But I just thought someone might like that and might find that interesting. It's actually cool stuff to me to see. That's the kind of cool stuff you can see with a scope that you can't see with any other tool, basically. And there's actually a lot more stuff you can do with the scope that I don't even know how to do, and that I can't even show you. But there's a lot of stuff a lot of information you can glean just from having these two waveforms. So anyway, I hope somebody out there liked that, and I will talk to you on the next one.